Hi guys, so in this video we will be solving this problem, swimming rising water. So first let's understand what the problem says. So in the problem we will be given a grid. Okay, so we have, it is a water, means we can travel in, swim in this grid, and we will be initially at the 0, 0 location, and our target will be this bottommost cell, bottommost and rightmost cell. We have to reach this well by swimming across this pool or whatever grid you can say. Okay, if we, there are some constraints, like if we are at a cell, then we can swim to 4 adjacent blocks, right? But we should be inside this grid only, so we can swim to the 4 directionally adjacent cells. Okay, and the value in this cell represents something. What it represents is that suppose if you want to travel to this cell, then it means that the height of water level in this cell is what, 13. So if you are at if your current level is less than or equal to 13, then you will have to wait for t equals to 13 second. And if your current water level is greater than 13, then you can simply skip through this cell, means you can travel, swim through this cell in 0 time. Okay, this is what this means. So let me clarify this once again. What I meant by this is, what will happen is that initially what will happen, suppose if we are at 0 comma 0 cell. Okay, if we want to go to 0 comma 1 cell, then what we will see, that height of water level is 1, which is greater than our current level, that is 0. So we will have to wait for 1 unit of time. Okay, now if I want to go from 0 comma 1 to 0 comma 2, what I will see, the current water level is what, 2, and the maximum water level which I have traveled till now is what, 1. So again I will have to wait for t equals to 2 seconds, or whatever is the unit of time. And this will go on, like we have to not sum up all the values, we have to minimize. The problem is that we have to minimize this time. We want to reach to this end bottommost cell, but the maximum time which we are taking in our path, maximum, not the sum, the maximum time which we will take in our path, we have to minimize that. Like suppose if I choose this path, for now if I choose this path, then the maximum time which I took in my path is which one, this 20 units of time. So I have to minimize this one. So if I take some other path like this, let's suppose if I took some path like this path, then something like this, then the maximum time which I took in my path is what, this is 16. So 16, and in this path it is 20. So I will consider this path because this is the maximum time which I stopped in my journey, in my path. Okay, so this is what the aim of the problem is. So now the problem would have been clear. So now let's see how we can solve this problem. Like the basic idea of problem is, this is what the basic idea of the problem. We have to minimize the maximum time which we stopped in our journey. And one more thing, like I have told earlier also, like if in my path I was initially at 0, at some in my path at some time I reached to, suppose I reached to height equals to 13. Okay, now again I move to cell with height, let's suppose 9. Then here I will not have to wait for any unit of time, because here the height of water level is what, 9, and in my path I have already come to height of water level what, 13. So I can simply cross this. Okay, so here I will have to wait for 0. Okay, so now let's move on to the solution part. Like the question would have been clear, I guess. So what we will do in this case, so what we will have a destination point, like we have our source. Initially we are at what, initially we are at 0 comma 0, and we want to go to destination. Our destination is what, 4 comma 4. So what are the steps available to us? So we can go to any of the 4 directions, top, left, bottom and down. So if I am 0 comma 0, then I can go to what, 0 comma 1, or and 1 comma 0, 1 comma 0, these two cells I can visit if I am at 0 comma 1. From 0 comma 1 again I can go to what, 0 comma 1 I can go to 0 comma 1 I can go to 0 comma 2, or I can go to what, I can go to 1 comma 1, and so on. So if we look clearly, this is what, we are moving one by one. So we will be applying BFS only. This is BFF. We will be also applying BFS only for solving this problem, but not exactly BFS. What we will be doing is that in BFS what we use is queue. Okay, but here we will be using priority queue. Intentionally we are using priority queue. There is a purpose for priority queue. Like we want to minimize the maximum waiting time, right? We want to minimize the maximum waiting time, and queue does not help us in that, whereas priority queue helps us. It helps us in finding a path which minimizes the, like suppose what will happen is that eventually we will start with this path. What will happen, we'll start with this point, and at a later point we encounter some very large value. So what we can do, we can revert back and check the other available options at that particular time. That can be done using priority queue only. But simple, if you use simple queue, then it will not help us in finding the minimum path. Let's take an example. Let me show you by an example how priority queue will help us and a simple queue will not help us in finding the minimum path. Let's take this. Let's consider a sub part of this problem. If we consider this matrix, this cell, okay. Let me give me a second. Okay, yeah. So if we have 0 1 24 23, okay, and 0 1 0 1, we are initially at 0 comma 0, we want to reach to 1 comma 1. If we use simple queue, then let's see what will happen. So what will happen, we will from 0 comma 0, 0 comma 0, what is the height of water is 0, so we will have to wait for 0 unit of time. We can go to what, we can go to 0 comma 1, sorry, 1 comma 0. This cell is 1 comma 0, 1 comma 0 with a height of 24. Since 24 is greater than 0, so we will have to, means if I want to visit from this cell to this cell, I will have to wait for 24 units of time. Similarly, from 0 comma 0 I can go to 0 comma 1, and my height is 0 and this height is 1, so it is higher than me, so I will have to wait for 1 unit of time. Okay, now we have completed this particular level. Okay, now we will move on to the next level. In the next level I will check 1 comma 0, and my destination is what, my destination point is 1 comma 1, sorry, 1 comma 1. So 1 comma 0 is not equals to 1 comma 1, so I will travel all the possible options from 1 comma 0. So from 1 comma 0 I can go back to 0 comma 0, but it is visited already, like we have already visited this cell, so no point of going there. So we will go to, from 1 comma 0 we can go to cell 1 comma 1. Okay, now here height of water is what, 23, and our height of water is what, 24. So initially we were at 0, now we are at a height of 24. Now I want to swim a cell which is at height less than me, so it will take me 0 time. Like, okay, so maximum time which I have waited in my journey is till what, 24 only, so I will show 24 here only. Okay, and from, so this part, no, from no other cells from 1 comma 0, I, what I told, why I stored 24 over here is that what we have to tell, the maximum time which we took in our journey, we have to minimize that. So maximum time I have taken in this path 0 comma, in this path is what, 24 only. That's why I am storing the maximum time as 24 only. Okay, now there are no more paths from 1 comma 0, so I will move on to the next cell, that is 0 comma 1. Is 0 comma 1 equals to destination? No, it is not. So I will travel all the paths from 0 comma 1 only also. So from 0 comma 1 I can go to what, I can go to 1 comma 1. And what is the cost will means time, 23. Here it will be 23 because initially I was at height 0, then I climbed to height 1, then I climbed to height 23. So 23 is greater than 1, so my time will be 23. So here it will be 23. Okay, now I have completed this level. I will move on to the next level. So I will visit this one. 1 comma 1 is 1 comma 1 destination. I have met the destination. And what is the time it is saying? It is saying that I took 24 is the time which I took to reach the destination. But if we look clearly, if we go by this particular path, then the maximum time which I will take in my journey is what, 23 only. But here it is on simple queue is giving us 24, because simple queue will not give us the shortest time. Okay, that's why we are not going to use a simple queue. We will be using BFS, modified BFS only, but we will be using priority queue, some Dijkstra type. This is, maybe you can call it as Dijkstra type algo. So we will be using priority queue because we are interested in finding the, means we want to minimize the shortest, minimize the maximum time we are waiting. So we are interested in shortest, so that's why we'll be using priority queue. Okay, so I guess this would have been clear, like why we are going with priority queue. So now let's see the algo in action, like how it will actually work. Okay, so we will be having a priority queue, so let's make a minimum priority queue over here. Let's make minimum priority queue. This is our priority queue. Priority queue. Okay, so initially our destination point is what? Our destination point is 4 comma 4, and initially we are at 0 comma 0. And what is the cost of 0 comma 0? Like height is what? 0 comma 0, height is 0 only, so we'll have to wait for 0 only. Okay, so one by one we'll remove elements from the queue. So we removed 0 comma 0 from the queue with height of 0, and we are checking, are we at destination? So we are not at destination. So what we will do, mark it as visited. Let's visit all the points where we can go. So if we go up, we will be out of the board, so we cannot go there. If we go left, then also we will be out of the board, so we cannot go there. So what we will do, we will move down. So if we move down, we will reach to 1 comma 0, and 1 comma 0 point is at height 24, and we are at height 0. So we will take 24 units of time to reach this particular point. Okay, from 0 comma 0 I can also go to 0 comma 1. So if I go to 0 comma 1, it is at height 1 and we are at height 0, so it will take us 1 unit of time. Okay, so I can go to these two locations. I will add this into my queue. So 0 comma 1 at height 1 and 1 comma 0 at height 24. Okay, now let's remove this element. Again remove, since it is a minimum priority queue on the basis of like maximum waiting time, minimum priority. So minimum is what? 1. So 0 comma 1 with weight of 1 will be out of the priority queue. Okay, now let's see, 0 comma 1, is it equal to 4 comma 4? No. So mark it as visited. Let's visit all the points where we can go. So from 0 comma 1, left is already visited, so we will not go in left direction. Well, if we go up, we will be out of the board. We can go down. So if we go down, we will reach to 1 comma 1, and our maximum height till now is 1, and this point is at height 23, so we will have to wait for 23 units of time. And if I go right, I will reach to 0 comma 2. Our maximum height till now is 1, and this point is at height 2, so it is higher than us, so we'll have to wait for 2 units of time. Okay, we cannot go anywhere else, so let's add this into the queue. So 0 comma 2 with height 2, and 1 comma 1, 1 comma 1 with 23 units of time. Okay, now let's remove the next element. Next element is what? Which is the minimum among this? 0 comma 2 with 2. 0 comma 2 with 2. Okay, market has visited. Is it equal to destination? No. Market has visited. Let's go where we can go. We can go from 0 comma 2, we can go to 0 comma 3. We are at height 2, this is at height 3, so we'll have to wait for 3 units of time. And from 0 comma 2 we can go to 1 comma 2 also. 1 comma 2 also, we are at height 2 and this is at height 22, so we'll have to wait for 22 units of time. So let's add it into the queue. 0 comma 3 with height 3 and 1 comma 2 with 22 units of time. Now let's remove the next element. Next minimum element will be 0 comma 3. 0 comma 3 on the basis of means height 3. So is it equal to destination? No. Market has visited. You can go to 0 comma 4. We are at height 3, it is at height 4, so we'll have to wait for 4 unit of time. And we can go to 1 comma 3 also. We are at height 3, it is at height 21, so we'll have to wait for 21 units of time. So 0 comma 4 with weight 4 and 1 comma 3 with weight 21 will be added into the queue. Now let's remove the next element. Next minimum is what? 0 comma 4 with weight 4. Is it equal to destination? No. Mark visited, where we can go from 0 comma 4. From 0 comma 4 we can go to only one spot, that is 1 comma 4, and it is, we are at height 4 and it is at height 5, so we will have to wait for 5 units of time. So let's add it into the queue. 1 comma 4 with weight 5. Now let's remove the next element. Next minimum element will be what? 1 comma 4 with weight 5. Since priority queue is on the basis of minimum weight, so always the minimum weight element will come first. So 1 comma 4 with weight 5. Yeah, this cell, is it equal to 4 comma 4? Not. So we'll mark it as visited and we will visit it neighbors. So we can go to what? We can go to 1 comma 3 with weight 21. Since we are at height 5 and this is at height 21, so we will have to wait for 21 units of time. And we can go to 2 comma 4 also. 2 comma 4, we are at height 5 and this cell is at height 16, so we will have to wait for 16 units of time. So we will add this into the queue. So 1 comma 3 with weight 21 and 2 comma 4 with weight 16 will be added. Now let's remove the next element from the queue. So next minimum is 2 comma 4 with weight 16. 2 comma 4 with weight 16. So is it equal to destination? No. mark it as visited. From 2 comma 4 we can go to 2 comma 3, 2 comma 3, and we can go to 3 comma 4. Now look clearly. From 2 comma 4, what we are seeing, 2 comma 4 is at height 15, and we have already traveled a height 16 in our path. So the maximum height we have traveled in our path, or the maximum time which we have taken in our path, will be what? Still 16 only. It will not, we will not reduce it down to 15. Otherwise, again we will have to means count it. So we have the maximum we have traveled in our path is what? 16. So we will consider 16 only as the maximum in our path. Okay. And for 3 comma 4, it is at height 20, it is greater than 16. So maximum time it will take in our path is what? 20 only. So we'll update over here. Okay, now let's add these into the queue. So 2 comma 3 with 16 and 3 comma 4 with 20. Okay, now remove the next minimum element. Next minimum element will be what? 2 comma 3 with 16, 2 comma 3 with height 16, 2 comma 3 with height 16. Is it equal to destination? 2 comma 3 and 4 comma 4 not equal, so it will be marked visited. This cell will be marked visited. From here we can go to, from 2 comma 3 we can go to where? 2 comma 3 we can go to 2 comma 2, 2 comma 2. Here also 16. Since here it is 15, but the maximum we have traveled in our path is what? 16. So we will write 16 only as our maximum. From 2 comma 3 we can also go to 2 comma 3 we can also 2 comma 3 we can go to 3 comma 3, 3 comma 3 with what is the height? 3 comma 3 with 19, 16 and 19. This is at height 19, so we will store 19. And from 2 comma 2 we can also go to this point, that is 1 comma 3, 1 comma 3, and its height will be what? Its height is greater than our height, so 21 will be stored. So 1 comma 3 with 21, and 3 comma 3 with 19, and 2 comma 2 with 16. Now let's remove the minimum element from the queue, but before that let's erase these elements, empty the space. Okay, let's remove these elements. These are now no longer needed. So yeah, so now let's find the minimum element. What is the minimum element now? 2 comma 2 with 16, 2 comma 2 with 16. So 2 comma 2 with 16, is it equal to destination? 4 comma 4 no. So mark 2 comma 2 as visited. From 2 comma 2 we can go to 2 comma 1, 2 comma 1, and here it is at height 13. The maximum we have traveled in our path is what? 16. So we will store 16 only. That maximum we have waited in our path is what? 16 only. And from 2 comma 2 we can go to 2 comma 3, sorry, not 2 comma 3, 3 comma 2, 3 comma 2. It is at height 18, so 18 will be stored. Since 18 is greater than 16, so we will wait for 18 minutes of time. And from 2 comma 2 we can go to 2 comma not 3 comma where are we? 2 comma 2. Yeah, from 2 comma 2 we can also go to 2 comma 1 comma 1, 1 comma 1 with 23. So let's add these into the queue. So 2 comma 1 with 16, 3 comma 2 with 18, 1 comma 1 with 23. Okay, this will be added into the queue. Now remove the minimum element. 2 comma 1 with 16 will be removed. 2 comma 1 with 16 will be removed. Is it equal to destination? No. Mark it as visited. From here we can go to what? We can go to 2 comma 0 with 16, 2 comma 0 with 16, and it is 2 comma 1, right? 2 comma 0 with 16, and 1 comma 1 with 23, 1 comma 1 with 23, and we are at this cell currently, right? We are at this cell. From 1 comma 1 with 23, and if you go down we can go to 3 comma 1, 3 comma 1 with 17. So let's add it into the queue again. So 2 comma 0 with 16, 16, and 1 comma 1, 1 comma 1 with 23, and 3 comma 1 with 17. Okay, now again let's remove the minimum element. Minimum element is what? 2 comma 0 with 16. So 2 comma 0 with 16, is it equal to destination? No. We will mark it as visited, and we will add the neighbors. Its neighbors are what? 3 comma 0, 3 comma 0 with 16, and 1 comma 0, 1 comma 0 with 24. These are the neighbors. Okay, let's clean this. Okay, so 3 comma 0 with 16, and 1 comma 0 16, and 1 comma 0 with 24. Okay, now let's remove the minimum element again. So 3 comma 0 with 16, 3 comma 0 with 16, 3 comma 0 with 16. Is it equal to destination? No. Okay, so we'll add the neighbors. Its neighbors are what? its neighbors are 4 comma 0 with 16 and 3 comma 1 with 17. Since 4 comma 0 is at height, then it is lower than our height, and we have maximum we have traveled or waited in our path is what, 16. So we will store 16 only. Okay, so we'll add this into the queue. So 4 comma 0 with 16 and 3 comma 1 with 17 will be added into the queue. Now again, let's remove the minimum element. Minimum element is what, 4 comma 0 with 16. 4 comma 0 with 16. Is it equal to destination? No. Market as visited. From here we can go to 4 comma 1 with 16, and yeah, this is the only point from where we can go. So we'll add 4 comma 1 with 16, 4 comma 1 with 16. Okay, now again let's remove the minimum element. Minimum element is 4 comma 1 with 16. Okay, 4 comma 1 is not equal to 4 comma 4. Market has visited, add the neighbors. So 4 comma 2 with 16 and 3 comma 1 with 17 will be added. 4 comma 2 is at height lower than us, but in our path maximum we have waited is what, 16. So we will consider 16 only. And 3 comma 1 is at height greater than us, so we'll have to wait for 17 units of time, which is greater than 16. So we have stored 17 over here. Okay, now let's add the elements. So 4 comma 2 with 16 and one more 3 comma 1 with 17. Now let's remove the minimum element, but before that let's remove the elements, some spaces. These spaces are not required to us. So the minimum element now is what, 4 comma 2 with 16. So 4 comma 2 with 16 will be removed. 4 comma 2 is it equal to destination? No. Market has visited, add the neighbors. So 4 comma 3 with 16 and 3 comma 2 with 18 will be added into the queue. 4 comma 3 with 16 and 3 comma 2 with 18 will be added into the queue. Again we will find the minimum element. Minimum element will be 4 comma 3, 4 comma 3 with 16. Is it equal to destination? No. Market has visited, add the neighbors. Its neighbors are what, 4 comma 4 with 16 and 3 comma 3 with 19. So 4 comma 4 is at a height lower than us, but in our path maximum we have waited, or maximum height we have reached, or maximum time we waited is 16 only. So we'll consider 16 only. So 4 comma 4 with 16 will be added into the queue, and 3 comma 3 will be with 19 will be added into the queue. Now again let's remove the minimum element. Minimum element is what, 4 comma 4 with 16. If we see 4 comma 4 is equal to destination, so we will stop over here. We have find the answer, and answer is what, 16 is the maximum time we have waited in our path. So our answer will be what, 16. So if we, there is a path, if we in this particular grid, in which if we travel that path, the maximum time we'll have to wait is 16, and that which is that part, this part. If we travel this part, if we see, waited for 0, we waited for 1, waited for 2, waited for 3, 4, 5, we waited for 16, now we waited for 15, but the maximum we have waited is what, 16 only. Means here we have not waited, since we have, once we have reached the height of 16, then we can directly go to height 15 in 0 seconds. So maximum we have waited till now is what, 16 only. From 16 to 14 we can go directly in 0 0 0 0 0 0 0 0 0 0 0. So maximum we have waited is what, 16 only. So and this is the path. Okay, so I guess the algorithm would have been clear till now what we are doing, but let's recapitulate it once again. So what we are doing, initially we are having a source, and we are having our finding our destination. And what we are doing, we are simply applying a BFS, but means modified BFS, not BFS, Dijkstra, something like that. But we are using a priority queue, and priority queue is what, priority queue of index. That is, we are what we are storing I, which cell we are currently at, that is I comma j, and along with the maximum, means maximum weight, something like that, maximum whatever we have done, and we are having minimum priority queue on the basis of this maximum so far. So what we are doing, each time we are comparing our element with what, comparing with destination. If it is equal to destination, then what we do, we simply return the maximum so far answer. Otherwise what we do, we explore all 4 directions, all 4 possible directions, and again continue this process. This is what we do. So I guess the algorithm would have been clear. So now let's do one thing, let's try to code this problem. Okay, so now let's code this problem. So as discussed, we will start with what we'll apply. We need a priority queue, let's make a priority queue, PQ. But as I told you, we need a priority queue of, we are storing indexes along with maximum so far, so we'll have to make an object for it. So let's make a class pair. Okay, in the public section, we'll make few variables. Let's make integer row, integer column, and let's make integer maximum so far. Let's define a constructor, integer row, integer column, and integer maximum so far. Let's initialize them. This row equals to row, this column equals to column, and this maximum so far equal to maximum so far. Okay, and we want our priority queue to be means on the basis of weight. We want minimum, so we will have to write a comparator for it, comparator class. So let's write class comparator. Inside the public section, we'll have to overload the operator. So let's overload it, bool of operator. Okay, we need a pair class object A and pair class object B, and what we will do, we will return A dot maximum so far greater than B dot maximum so far, since we want minimum weight first. Okay, so let's make a priority queue of class pair. We'll use a vector to store the elements, vector of pair, and we have passed the comparator comp. Okay, initially what we will do, we will add our, that is what we are doing. Initially we were adding our source node into the priority queue. So let's add that priority queue dot add pair of 0 comma 0, that is 0th index, and the height of water at that cell is what, the grid of 0 comma 0. After that we simply apply the BFS type, means modified BFS, something like that. What we do, one by one we remove the element and check with the destination. If it is equal to destination, then we simply return the maximum so far value. So what we will do, pair removed element is equal to priority queue dot top. Okay, and then we will remove it from the priority queue. Okay, then we will check if removed element dot row is equal to grid dot size, and removed element dot column, if it is equals to grid of 0 dot size, that means we have reached the destination point. So what we will do, we will simply return removed element dot maximum so far. Otherwise what we will do, what we are doing, we are checking if it is visited or not, and if it is not visited, then we are marking it visited, and we are exploring all the 4 directions. So we will check if this element is visited. If this element is visited, then we will simply skip it. If visited of removed row and remove dot column, then what does it mean? We don't want this, we'll simply skip this. For that, first let's make a visited array, vector of bool visited of grid dot size, and vector of bool of, where were we, vector of bool of grid of 0 dot size, grid of 0 dot size. Okay, and if it is not visited, then what we will do, we will mark this as visited. This is what we were doing over here in the diagram also. Remove dot column equals to true. Like what we were doing each time we were visiting a node, like when I was at 16, what I was doing, I was comparing it with the destination. If it was not destination, then I was marking it as visited. Okay, so then the same we are doing, marking it visited. After that we were exploring all the 4 possible directions. So for integer I equal to 0, I is less than 4, plus I. Okay, for that we will need a direction array. So let's make a direction array, vector of integer direction in x, and similarly we will make direction in y. And if we are at this point, what we were doing, what are the 4 directions? These 4 are directions. This is what, -1 0, this is what, 0 plus 1. Similarly this is what, +1 0, this is what, 0 minus 1. This is what we will do. So direction in x is what, direction in x is -1 0 plus 1 0, plus we can simply write z plus, and direction in y is 0 1 0 1 0, and -1. This is direction in y. Now one by one let's calculate. So our new row will be what? Our removed element dot row plus of dx of I. Our new column will be what? Removed element dot column plus of dy of I. If we will check if it is out of bounds, means if it is row is less than 0 or column is greater than 0 or row is greater than equal to grade dot size or column is greater than equal to grade of 0 dot size, or the cell we want to visit if it is already visited, if visited of row comma column, then we will simply skip this cell. Otherwise what we will do, we will add it into the queue like what we were doing. If it was any of these condition was filling, we were not visiting the node. Otherwise what we were doing, we were adding it into the priority queue. So what we will do, priority queue dot push pair of row comma column comma maximum of removed element dot maximum so far and grade of row comma column, right? And finally we were, since the function signature says that like we have put a return value by default integer, so we'll have to return 0. Our answer will be returned from here only, but since we don't get compilation error, that's why I'm writing this. And here we have written maximum, since as you can see, like we were storing at each time what the maximum we have waited in our journey so far. Like till now here it was 16, but from this here onwards also what we were storing each time 16 only, because the maximum time we have waited in our journey was 16. That's why we have stored maximum over here. So this is the code for the problem. Till now we have not uploaded the test cases over here, but the time when you will code, the test cases will be uploaded. So this is the code, it will work fine. So you can try to submit over there. Okay, so I guess the solution would have been clear to you guys now.